Astronomy Cast, episode 422, Geysers. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Fraser Cain. I'm the publisher of Universe Today, and with me is Dr. Pamela Gay, the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well, Fraser. How are you doing?
Doing great, and I know we've been sort of saying this every week, but once again, another reminder, go to astronomycast.com/events, and is that right? Or live events?
Just go to our homepage.
Yeah, there'll be a link there.
astronomycast.com.
And find out
There's
how you
a
can hang
link
out with
that
us.
says trips. The actual link is like stupidly long. So just go to astronomycast.com.
Yeah, astronomycast.com, and then there's a link to the trip. Remember, we're going to be hanging out at the eclipse. We've already sold half our tickets. The rest are going to, we haven't even really cranked up the marketing efforts. The other half are going to go pretty quick. So join us and watch the eclipse. This is crazy. I'm really looking forward to it. And also, as I mentioned in the Weekly Space Hangout, Elon Musk, please don't break our hearts. That's all I have to say. So if you've been to Yellowstone National Park, you've seen one of the most amazing features of the natural world. Geysers. In today's episode, we're going to talk about geysers here on Earth and where they might be in the solar system. And of course, this topic was picked also because of the amazing discoveries made on Europa and the new evidence. So we'll be talking about that as well. So let's talk about geysers here. Have you been to Yellowstone? Have you seen geysers in your life?
I have. Back the summer between my junior year in high school and my senior year in high school, when normal kids were going on college visits, we instead went on a tour of national parks because I already kind of knew where I wanted to go to college. And among the many, many national parks we went to that summer, we went to Yellowstone and we saw Old Faithful, and we saw a whole bunch of other boiling, bubbling, sulfury, gross, hot, will kill you things oozing up out of the ground, because that's what you do at Yellowstone.
I've never seen a geyser in real life.
You need to fix this. You need to take your children and fix this.
I'm working on my bucket list. I just saw a rocket launch, so cut me some slack here. But it's amazing. And so Yellowstone, do you know how many they have? Like, they have a bunch, right? They have Old Faithful and they have others.
It's actually the highest concentration of geysers on the planet. There are actually very, very few places on the planet Earth that have geysers, because the required conditions, it takes a lot to get a geyser. So the only places on the planet that we really see geysers are up in Alaska. We have them at Yellowstone. There's a place in Chile, out in the easternmost islandy area of Russia, Iceland, like all of Iceland, and then out in New Zealand. All of these places have a lot of volcanic activity, and they're the only places, just 6 places on the entire planet that have geysers. Yellowstone has the most. It has a couple dozen of them, but they do come and go with time. So geyser today, hole in the ground tomorrow.
Right, and so the key with Yellowstone, of course, is that there is a supervolcano underneath, which is generating all this volcanic activity. And one of the interesting side effects of having a supervolcano that could utterly devastate a goodly chunk of the continental United States is there's some really pretty geysers.
This is true. And Old Faithful's the one that we know the most about. This is one that goes off roughly every 60 to 90 minutes. Due to drought conditions, it seems to be taking longer and longer to re-explode. But it only shoots stuff into the air anywhere between 100 and 200 feet, divide by 3 to get to meters. But there are others that blast steamy water significantly higher. There is one called Steamboat, which its last eruption was in July 2013, as far as I know. It seems to go off every 5 to 10 years. And when it goes off for about 10 minutes. And geysers 300 feet. That's like 100 meters basically straight up. So
It takes years for it to go off?
yes, it takes that
Wow.
long for it to build up the pressure, build up the pressure, build up the pressure, undergo massive phase change, explode steam into the air.
Oh, okay. I was going to try and show. I'm going to show off a little bit of Old Faithful for the folks who are watching the live stream. Which, by the way, if you want to watch us live, we do the show every Friday afternoon. So I can even play some audio. Well, it won't help for the podcast. So that's just amazing. Yeah, bucket list. I've got to go and see a live geyser. Clearly, this is going to be on my list of things to do. So what is causing the geysers of Yellowstone, and then we can sort of go to some of the other places?
So geysers on the planet Earth, which is actually the only place that there are true geysers in the geological definition of what a geyser is. True geysers, you have a underground cavity of some sort that has extremely hot rock beneath it. This cavity with the hot rocks beneath is filling up with water. As it fills up with water, it's held under pressure in this cavity, filling up with water, filling up with water. That water is heating up. And as anyone who's watched the stove knows, it takes time for water to heat up. So you have two things happening. Water flowing in, that water is getting heated by the hot stuff underneath. Now, because it's all held under pressure, it is able to actually get superheated. This means that it's able to get well above the boiling point, well above that point where it wants to be steam, before it finally manages to break free, gets so hot that it explosively goes from water to steam, all of it kind of all at once, and explodes through a fissure at the top of this cavity.
Right. And we can get those not only in places like Yellowstone, but we can actually get those down at the bottom of the oceans as well, right? We get these really cool underwater geysers.
Well, with the things that we see underwater isn't so much geysers as we do have underwater volcanoes, underwater fissures in the earth that allow magma to escape, lava to escape. And in these places, water does actually get brought up to boiling, but it's the water at the bottom of the ocean. So it's a kind of weird situation. And it's also held under pressure, so it's happening at different temperatures. Most of the time, you just end up with smoke and gas and stuff coming out, and you end up with these underwater smokes. But there was recently a case of a brand new island coming into existence and almost taking out a boat in the process, where the underground volcano, and these people in a yacht out cruising around were like, what is this weird stuff all over the surface of the ocean? And they go sailing over, and they're like, there's pumice floating all over the ocean. What is going on? And then they notice the ocean is kind of bubbling, and so they go away quickly. They back away from the pumice expanding across the sea, and then all of a sudden, kablooey! New island is explosively formed, lots of bubbling, boiling, new island. So we do have all sorts of, the planet's alive. The planet is alive. But the only place where we do see this geyser experience, which is separate from volcanic stuff, the geyser is the heating of the water explosively undergoing phase transition, coming out through the surface as steam, shooting into the air, emptying out the cavity, allowing the process to start over.
Now, we don't have any geysers here that I know of in Canada, but here on the West Coast, we have a bunch of hot springs. So is it kind of the same process, but just more extreme?
So with hot springs, it's not that you have this explosive phase transition going on. Springs happen everywhere. Springs are simply a place where you have water that seeps up from underground through the surface. It's where an aquifer, an underwater reservoir, an underground stream, like whatever form of underground water it is, escapes onto the surface. This is where rivers start, springs start, streams start. They're great sources of drinking water, and they come in hot and cold. The hot ones exist where, like you have there in Vancouver, there's lots of local volcanism, and that volcanism is heating the rocks underground, and these heated rocks are then heating the water underground, and then the water is coming up through the surface. So it's just a regular spring that happens to be near hot rocks.
So Yellowstone is the one place we talked about. Where else can we see them? Iceland?
Iceland is kind of covered in geysers. It's this is what happens when you have a new section of land being kind of formed all the time. We also have these out in the southern area of Alaska, where there's, again, lots of active volcanoes. Then if you go all the way east in Russia, out to the part of Russia that's just north of Japan, there's a lot of active volcanoes there, and also geysers. Then in Chile, where there's active volcanoes, there's a small area of Chile where there is also geysers. And then northern New Zealand has geysers. Again, all of these are tectonically, volcanically active parts of the planet.
So we've talked about what the geysers are on Earth. Now let's take this concept and start to explore the solar system with it. So where else do we find geysers in the loosest sense of the term around the solar system?
So here's the thing. We misuse the word geyser all the time. It's just sort of like you might grab a tissue that is made by a company that isn't Kleenex and you still call it a Kleenex because it is a rectangle of flimsy stuff that you can use when you have a cold or to clean your glasses, but it's not a Kleenex. So when we see stuff spewing out of the surface of a rocky body, and that stuff happens to be water in nature, we call that a geyser, even if it might not actually be a geyser. And we see not geyser places where volatiles like water are getting shot out the surface of the world, kind of all over the outer solar system. So Triton, we noticed with the Voyager missions. Enceladus, we were able to see these around Saturn. Then Europa was the big discovery this week. But all of these things aren't geysers. They are sometimes called cryogeysers, which is a little bit closer to the truth. Cryovolcanoes is the more, if you start digging through what not astrophysicists, if you start digging through what geophysicists and planetary scientists want them to be called, those are better terms.
They're like cryovolcanic plumes.
Yes, they are.
Right. And so in this case, because they're not getting heated by rock, is that sort of?
Well, it's actually that lack of phase change that's going on. So, for instance, when we look at Enceladus or Europa, where we think subsurface liquid water and subwater tidal heating of some sort, so hot rocks, we don't have a phase change to steam. What we have is a cavity that is getting filled with melted water, and that melted water does get pressurized and then goes up through the vent in the ice, whether it be a crack or whatever, and escapes as vapor but not as steam.
Well, so let's talk about what's going on then with Enceladus and Europa. Let's start with Enceladus just because I feel like the evidence is a lot clearer, and we've definitely seen this thanks to Cassini flying around and around and through the plumes. So what's happening over on Enceladus?
So what I love is you're asking me something that the general answer is I don't totally know, but it's awesome.
Yeah.
Sometimes that's the answer you get in science. So what we see is this icy moon has dark stripy bands that we have actually named well. They have the awesome name of tiger stripes. And this may be like one of the very first times I've said something was named well in astronomy and space science.
As opposed to black holes, Big Bang.
Yeah.
Worst names, yeah.
Yeah, so the Cassini mission, which is slowly working out through the last parts of its orbits, early on revealed that there are four dark tiger stripes, and these appear to be some sort of a linear depression. So it's not just a color difference. There's actual like topography associated with these darker stripes. They're about 2 to 4 kilometers wide, about half a kilometer deep. So these are big structures. And there's evidence that these plumes of vapor, of volatiles that we see exploding away, being released with violence away from the surface of Enceladus, are coming out through these tiger stripes.
Right. And, not truly geysers, but cryovolcanic plumes. One of the really exciting things, we'll talk about this with Europa as well, is that, with the discovery of these, that these objects probably have some kind of ice shell with some kind of liquid ocean underneath, then you're like, well, we want to explore those oceans. We want to see if there's life there, because wherever we find life on Earth, we find, wherever we find water on Earth, we find life. And so the analogy is like, we should totally go send a submarine down into these worlds and find out if there's any life down there. But Enceladus and now Europa have been spewing this material off into space that we can literally just fly a nose through and find out, taste, or a tongue, taste the chemicals, taste the organic material, taste the soup.
I think rather than taste, it's better to say we're going to do mass spectroscopy on these suckers.
Or taste. Spacecraft version of tasting. But yes, I agree with you. So we've talked about Enceladus. So let's talk about Europa, and first let's kind of roll this out a little bit, and because the big announcement this week, but there was actually some previous announcements and some theories and some hints and speculations. So give us a bit of a history on this discovery.
So one of the things that I started off describing was with water geysers here on Earth. You have a cavity that fills up with water, ends up under a lot of pressure, kablooies out through the top. And this is a regular process sometimes, where like Old Faithful every 60 to 90 minutes. But then Steamboat, we're looking at every many years. And so this is one of those processes that can take a long time. Now, with Europa, Hubble Space Telescope had taken a good look at it several years ago and had seen hints that there was something off to the side reflecting light. It had been captured in infrared, and there was this, is that geysers? Are we seeing? Yes, I know geysers is the wrong word. I'm the one that said that earlier. There was this, is this a plume? And we wanted to believe it was a plume. We want Europa to have liquid near the surface. And we kept looking, and there's all sorts of stories with headlines like, Europa's plumes disappear, Europa's plumes unconfirmed. Were we seeing things? And scientists are diligent. We are capable of just sitting there waiting for the pot to boil, waiting for the pot to boil, waiting for the pot to boil. And we don't know how many times it boiled when we left the room, and then someone came along and added cold water. But eventually, Hubble looked back again, and once again was able to catch these plumes in the moment going off using Hubble Space Telescope.
Right. And so I guess the key here is that it was caught, that it's not constantly going off. Like Old Faithful, there is some time in between, and then the event, the geyser goes off. But in this case, the cryovolcanic plume goes off, and it happened to be seen by Hubble.
And what's amazing is looking at Europa, you again see these cracks in the surface. You again see these different colors in different parts. There is a chemistry to these worlds that is getting revealed in what's allowed to escape through the surface. And And it seems to be that this is a fairly common phenomena. Back when Voyager flew past Neptune and captured images of Triton, we got these beautiful images that seemed to demonstrate plumes that had settled back over 150 kilometers to the surface of this icy world orbiting Neptune. So here we've got plumes coming off of the moons of Saturn, of Jupiter, of Neptune. This is a common phenomenon that we're still struggling to understand. We don't have the ability to do all of the testing we can do down here on Earth, where we can actually start to like map out these chambers and follow the entire process. And we can't do that yet on these distant icy moons.
But it's possible that, that these kinds of under ice oceans exist across all of the icy bodies across the entire solar system, not just Europa, not just Enceladus, the ones that are even having these gravitational interactions. It's possible they're on Pluto, Charon, Eris,
and this is
Sedna.
where we get confused, because we can understand how Europa is getting heating. It's tidally locked with several of the other moons. It's getting regularly distorted. We can see the reflections of differences in rotation between the surface and subsurface in the cracks. We understand Europa getting internally heated through tidal forces. We can get at how that would happen with Enceladus. But when you start looking at Pluto, it's a tiny world. It just doesn't have the levels of getting squished and released that we thought were needed. But, the universe likes to prove us wrong by being far more interesting than our human minds could imagine. And so now we're trying to understand how it is that we appear to have a young, active surface on Pluto. And we don't know yet what all we're going to discover as we continue to dig through these brand new images that are still coming down from New Horizons.
Yeah, it was great. When we talked to some of the scientists in advance about what they were expecting to see at New Horizons, nobody expected to see what they saw on the surface of Pluto. They were not expecting to see this young surface. They would have expected something that was ancient, icy, but not necessarily with these like mountains of water ice but also the fresh, clean parts of the surface as well. This was a total surprise. And so I guess, are like the cryovolcanists and the geyserologists the new cool kids with all of this stuff being discovered?
Well, I think this is actually more along the lines of the planetary science equivalent of trying to understand magnetic fields. It's one of those complex modeling problems of how do you guess at what's happening at what level and what is driving what, and you have to make estimates of the amount of radioactive material that's providing heating and all these other different things to try and model it starts to become hydraulics. And so here we have the hydraulics of icy moons is that new magnetic fields scary question of, well, how does magnetic fields affect that? Well, how does hydraulics affect icy moons?
So let's talk a bit about what this means for the search for life. If you talked to scientists 20 years ago and said, where should we be looking for life? Most of them would have said Mars.
Yeah.
And you talk to them now and they will all tell you
Europa.
So, what do these geysers, if they have, if we can confirm these geysers, find their locations, figure out what's causing them, what does this tell us about the potential for life on Europa?
It tells us that there is a thermal gradient on Europa, and it's a thermal gradient that's that third thing that's required for life. You have to have nutrients, you have to have a solvent, and you have to have a thermal gradient, and we know the solvent is there because water. We don't know yet if there's nutrients, but we keep finding organic molecules pretty much everywhere we look in our universe. Nebulas, other worlds, they're just about everywhere. So now it's the let's go flip this rock over and look to see what bugs live underneath it, except it's actually more like, let's go dig down through 5 kilometers of ice and see what's beneath it. And there could be bugs, there could be jellyfish, there could be protozoa, there could be single-celled things that don't even have
Space
nuclei or
whales.
mitochondria. There could be space whales, but that one I doubt.
Come on, space whales.
Well, I think space whales would require an atmosphere, so maybe space sharks.
Mm-hmm.
Whatever it is has to live fully submerged.
Yeah.
But now we have this great unknown. We know that the thermal vents in the bottom of the Earth's oceans are rich with life. And so, I mean, it could be Enceladus, Europa, Mars, all completely dead, nothing alive there. But it could be that we're going to find some alien version of what we found down in the Marianas Trench here on Earth. A completely new ecology that when you and I were kids, we were told totally could not exist because there's no sunlight. Now we know our books were wrong.
So
why we do science.
I don't normally mash the chat with the live show with the episode, because the people who are listening can't actually see the chat that happens during our live show. By the way, if you're listening to this, we do this live and you can come and watch us and hang out with us. But Tang just gave the name for what these must be called: Geysers. So
I appreciate that. Yes.
Yeah. So Tack, that's fantastic. I am going to make sure that all of our writers on Universe Today start using that term now. We're going to make that stick. So Geysers.
That's far
perfect.
better than cryo geysers.
Yeah. Yeah. Exactly.
I like geysers.
So let's, before we sort of wrap this up, let's talk about missions to Europa that can help us get to the bottom of this. So, boy, sure would be handy if there was a mission that had recently arrived at Jupiter with the capability of viewing Europa a little better. Does this exist?
Well, so we have the Juno mission. Juno wasn't exactly designed to explore Europa. In fact, it was kind of designed to stay the expletive away from Europa because we don't want to pollute Europa with our Earth germs.
Also, attempt no landing there.
Right, exactly. 2001 Space Odyssey got that one completely right. So we do have a spacecraft out there. Its mission is not, can't say this enough. Its mission is not to explore Europa. Its job is to explore the gravitational field, the magnetic field, the magnetosphere, the poles, all the cool parts of Jupiter that we want to know more about. So it's there to look at Jupiter. That's the name, Juno. So, hey, Congress, I'm looking at you. Hey, European Union, I'm also looking at you. Can we have money for science? Can give us a spacecraft, please? There's lots of us that would want your spacecraft money.
But isn't there a mission to Europa in the works?
There is a mission in planning phase. It is not going to be one to land and explore. It is one to orbit. So yeah, there is a clipper in the plans. They've announced all of the instruments for it. It's in the process of being built. We do have some serious technological hurdles to figure out before we can go land. Like, how do we do this without killing everything there with like the single-celled version of smallpox?
Yep.
But
that's a very dark analogy, but yes, we understand.
Yeah. So we also, when they awarded all the instruments for the clipper that we're sending to Europa, we didn't know yet about these plumes. And so I'm sure there's instruments that people would love to get the chance to go back and do a little bit of re-engineering on, which will take a little bit of money, to just take advantage of all of these new results we have from Hubble.
It should be called Chrysler and then have some kind of acronym that, cryo, volcanic, I don't know. There's the rest of the acronym. But anyway, yeah, absolutely. So the point is that very fortunately, with these kinds of discoveries, Europa has become really the center of attention for both NASA and ESA. And I think that we should see a lot more close-up pictures and information on Europa shortly. And we'll get to the bottom of this and try and see how many there are, where they happen. I mean, we really need a spacecraft like Dawn that's going to go into orbit around Europa, stay there, and study it to the nth degree at super high resolution. Like I'm bored of these same Europa pictures that we keep having to look at. I need new ones.
They're kind of stunning. So yeah, I get that
Boring,
you're bored with it.
Bored. Come on, like the new pictures of Pluto, that was the greatest thing ever. And now I got Pluto pictures for years. So
we will at least have a mass spectrometer. The currently planned spacecraft has a plasma instrument for magnetic sounding. It has a magnetometer, which is named IceMag because of course it is, which is going to do internal characterization of Europa. We have a mapping imaging spectrometer, which basically means you look at the surface with the kinds of cameras that let you go, and there is CO2 here, and there is H2O there. Then there's, of course, an imager, so we will get those shiny, pretty images that you want. There's a radar. There's a thermal emission imaging system, which is a fancy way of saying we're going to be able to tell what the temperature variations are across the surface. There's an ultraviolet spectrograph to just give us more information beyond what our eyes could see. And we are even going to be catching dust to do a surface dust mass analyzer. So it's a complicated mission. It's going to do 45 flybys of Europa at altitudes varying from 1,700 miles to 16 miles and will not crash into the surface. But we have a few years to go.
That sounds exciting. All right. Well, thank you very much, Pamela. We'll talk to you next week.
My pleasure.
All right. Let's save this.
Welcome to the boring part of the show in which you watch us not lose the episode. This is 422.
Uh-huh. And then I'm going to need people to help me. Apparently, there's a problem with my audio where it is trying to be stereo.
Oh.
Yeah. So if people can help me get to the bottom of this. Is it when I touch the microphone? Have I got like a cable that's loose? I don't like this. An intermittent problem is the worst kind of problem there is. So don't be surprised if I take the whole microphone, get up, and just throw it out in the garbage. Is it my
Fraser's method of solving problems is to buy new equipment.
But I thought I'd found it. I thought I had found my way to the promised land. But I don't know. Are people who are hearing it in the podcast? Because we would have gone through it last week. So if people can tell me, get to the bottom of it. So I just did a Google search, and Geysers has never been used. So this is it.
You Googled a term that doesn't actually return results?
Well, no. I mean, apparently there's no. Like literally, there's a person who plays video games named Geysers, and likes to play a lot of Call of Duty and League of Legends. So I apologize, Geysers, if that is your real name, but we're going to steal your name and turn it into a term for describing cryovolcanic plumes.
That was a sad noise.
Maybe I switched to a different microphone pattern. I've changed the pattern on my microphone. Let me know if that helps. I've also there's like a big cable on the bottom, and I guess I should just listen. I'll plug into the headphones on the microphone and then just hear what it does. But anybody want a half broken microphone? I'll try my blue Now you can give me all the complex, okay? All right.
So Simon Love is asking, couldn't artificial geysers be used as some form of launch system? Well, it's kind of what we already do, because the way a geyser works is water changes in volume by a factor of about 6,000 when it goes from liquid to gas. And with the launch of a rocket, you're taking your oxidizer and your fuel, mixing them and causing them to explosively change volume as they go from a liquid or solid to a gas. And so it's the same concept, but you're not waiting for natural replenishment. But yeah, same physics.
All right. So William Van de Beek asks the question that will then now take us the entire rest of the episode. What does Pamela think of Musk's vision?
I think we need to solve how to not kill people with radiation, and then I'll deal with the rest. I just want that problem solved first.
Boring.
I think coming up with technological solutions is fabulous, and I think his plans would be great for sending robots. Yay, science! Good. But like, I don't want people to die.
Mm-hmm.
I mean, I like predictably die. People are going to die in the process of exploring Mars and figuring this out. But there's a difference between sending people that have a potential to survive and sending people who are counting on the luck of the sun not having a coronal mass ejection while they're traveling through space.
Right. Okay. So I mean, everyone, I hope, who is watching this knows what the problem, knows the mission that Elon described earlier this week. Like, you literally have to have been living in a cave to not know what happened.
80 days to Mars.
80 days to Mars, 100 people at a time, $100 to $200,000 cost to get yourself to the surface of Mars. A revolution in the size of booster technology and reusability, using methane rockets at a scale that's never been comprehended. Like, there's all kinds of stuff. So let's talk just about this radiation problem. So he was actually asked by, like, the one cogent question.
The questions are priceless.
Yeah, the one cogent question in that entire talk, surrounded by just the weirdest questions, was, you know, what do you think about the radiation problem? So that question was asked, and he said, I think the problem of radiation is overstated. And this is not the first time that I've heard this comment made. Bob Zubrin from the Mars Society makes a very similar comment, which is, yes, radiation bad, more radiation, more bad, but it is a achievable solution either through the way you pack the spacecraft and the way you put the people, you know, protected by their water, by their surroundings, the kind of shielding that you use, that this is like a increase of cancer problem, like with, you know, like when you take dental x-rays, like, you know, like they give you a lead suit to wear, but you're still going to get your dental x-rays because the risks are greater, but they're not, in theory, lethal. So what do you think? Do you think he is understating the problem?
I think that whoever's in the center of those 100 people is probably going to do pretty good, but anyone who's on the outskirts of those 100, I wouldn't want to be them. I think it's the kind of thing that you certainly can't do during solar maximum.
Yeah.
It's the kind of thing that the risk during solar minimum is still pretty high, and something that only works when the sun is mostly turned off when it comes to solar stormy activity. I don't consider quite a solution that I'm willing to go with yet.
Right. Like if the astronauts, if the 100 are caught during a solar storm and it actually passes them, they're all dead. Dead.
Yeah.
Dead within 2 days. They all
Yeah.
take a lethal dose of radiation and then they all die.
And it's a horrible way to die. If you truly hate yourself or truly think it's cool to go to Mars without radiation protection, go read in detail about what happens when you die of radiation poisoning. It is, behind death by fire, the worst way to die, in my opinion.
Right. As you liquefy and
Yeah.
So okay, so that because like with the astronauts on Earth, they're protected, or the astronauts in the International Space Station, they're protected by the Earth's magnetic field.
Yeah.
The astronauts who went to the moon, there was a risk of a solar storm, and for astronauts going to Mars, it's almost inevitable that someone's going to get caught in one of these storms. That at some point, one of these missions, they're going to get hit by a storm, and they're all going to get hit. Once they land on the surface of Mars, they go underground. Then it's not so bad.
And what I'd really like to see is a mission first to the moon that practices the whole idea of dropping ourselves into a cave and exploring, and then goes to Mars, which is a much more expensive way to accidentally destroy your rover, and practices that rappelling into a cave. Because if we learn that there actually isn't solid footing as you approach the top into one of these caves, we need to know we can get into a cave safely, basically.
So that's sort of one of the first questions. And then I think the second thing that a lot of people have been sort of addressing, and we talked about this in the Weekly Space Hangout, is just like Musk's plan was very short on details about what do people do when they get to Mars, right? Like,
why are we sending 100? Because that's a lot harder to feed.
Yeah, I'm imagining, you're kind of imagining these spacecraft landing on Mars and then pouring out and like standing on the surface, like what do we do now? Here, and then even like the final, like it's hilarious. Like you see the final scene of the video, and like the doors open, and there's just this desolate surface of Mars. Yeah. The rocket's out of fuel. There's a bunch of astronauts just standing there, and they're just like looking around in their spacesuits. Yeah. What now? So what do you think about how, do you think that it's time to send colonists to Mars, or do you think we're a little early on that?
I think we're a little early on that. I think that we need to figure out, there's so many problems we need to figure out first. It feels a bit like, do you ever read Scientific American where they have at the beginning the appeared 25, 50, 100 years ago column?
Yeah.
Yeah. So reading through those, you'll see things that passed, and there's a lot of times these amazing inventions that people are announcing, and then they never make it to fruition, because it turns out that when you actually start working on the details of these problems, that they don't quite work the way they'd be liked. Like my favorite is a few years ago, and it may not even be quite a few years ago, it may only be 1 or 2 years ago, there was this big announcement about effective solar panels that can be embedded in roadways that change what the surface of the road looks like, light up, different conditions. Amazing. And it turns out they don't work so well with all of the thermal variations of reality. And so it feels a little bit about one of those, and we have a vaccine that should make it to the public in 3 years that 20 years later we still don't have.
Okay, so would you like a super heavy lift system capable of almost full reuse, in fact, of full reuse, where all it has to be is refueled, right? Like, I'm sure when you saw that rocket and you're like, yeah, please.
Everything that we need to try and make this mission possible, we need. I don't think we should not try. I think we have to try, because trying is the only way we actually find out what can and can't work. I think that given that this is commercially funded, we say, hey, we will open access all of our federally funded research. We'll hand you everything we've developed with federally funded money. Take our ideas, run as far as you can, take every risk you can. We're going to be overly cautious with tax dollars and sit over here in our overly cautious box. I think we need to encourage the genius of the Elon Musks, the Howard Hughes, the billionaires with the engineering to go forth and innovate things that may or may not work, but if we don't try, we don't get anywhere.
Didn't it feel like it was like just like Space Nerd Christmas? right? When are we go to space? When are we going to become the interplanetary civilization that we've always dreamed of? And then Elon Musk, like, not only said, well, here's how, but like, and I'm working on the rocket, and here's all the pieces, and it's going to happen at a scale that you can't even comprehend. You know, you'd like 10 people walking on the surface of Mars. I'm going to send 1 million, you know? It was just like, what?
I read Red Mars. This doesn't end well. I need to read less dystopian sci-fi.
Seven Eves, maybe, you know, when the destruction of the Earth is at hand and you've got no other choice, you know, they barely get enough people into space to keep the civilization alive. Like,
yeah, so I think we need to try. I am a doubting Thomas when it comes to a lot of these things. I want it to be true, but I'm just not there yet.
Yeah. But do you think, like, if he literally says, okay, the prices are here, it's $100,000 US, and you get a return trip, right? Like, you get to the surface and there's going to be all these leftover colonization ships kicking around, and you feel free to refuel them and send them home and come on home. You know, like, would you, for $100,000, go to the surface of Mars for a couple of years, assuming it was reasonably safe, right? Like, when it's described that way, I think there are people who will be like, yeah, I'm up for the adventure to colonize Mars. And other people are like, yeah, I'm up for the adventure of going to help them colonize Mars and then coming home because Earth is the best.
Yeah, and here I get to the point of more my reasons for saying no have to do with things like, well, you and I have both been on cruises, and we know that whole line up for dinner, line up to leave the ship, line up to get on the ship, lemming experience that you have while going on a cruise. And I get the feeling that going to Mars with 99 other humans might be kind of that without the gourmet meals. And so it starts to become more of worrying about ending up with, like, it takes just one crazy dude on the trip with you to make the whole thing a sad, sad experience. So I start to hit personal reasons not to go. Mm-hmm. But I think that if we can get to the point that it is that future you're describing, me saying, not my thing.
Yep.
I'd rather go to Iceland is a personal choice, not a scientific choice. And
right.
More power to all of the people who don't mind being lemmings.
But do you think there would be a lineup of people willing to spend the $100,000 or $200,000 to go and live on Mars?
And many of them will be crazy.
Shh. But I guess that's the thing, right? Like, on the one hand, I'm like, you know, there's no way this is going to happen. But if the price is right, there will be a line of people wanting to go and spend some time on Mars.
Well, how many people have spent $250,000 reserving a seat on Virgin Galactic?
Yeah.
And we don't know when that's actually going to happen. They've simply reserved a seat. If they're willing to spend that much to go into low Earth orbit, there's going to be people who don't have time constraints that are down with being gone for an entire year or two and will spend the money to do it. It is definitely something for the ultra rich, but it is something people will sign up to do.
But $100,000 is not the ultra rich. Like, $100,000 is an amount of money that a person who saves really hard and takes out a Mars mortgage could do, or a company looking to send one of their employees over to Mars to.
The employees thing will happen. The thing that I'm looking at with the 100,000 for an individual person is you have to worry about not just the 100,000 that you have to spend to go, but the lost income while you're traveling, and the money. You either have to sell everything you own, which probably makes more sense since you might die, or you have to pay storage and upkeep. And it's, when you go on vacation for 2 weeks, or military people who go on deployment for 6 months, there's a whole lot of random costs associated with that. So I think the 100,000 is the ticket cost. And then there's I have to buy my own spacesuit. I have to buy this. I have to buy that. I have to buy this other thing. Now I have to pay for, sorry, I'm letting reality get in the way.
Yeah. Pesky reality. Cool. Well,
I've been working on budgets all day.
So apparently my mic just messed up again. So there you go. There's that. And my CPU is grinding up. So I wonder if this software that we're using is not quite as great. It's leaking a little bit. We'll see.
You may have needed to reboot ahead of time, or did you remember to shut off Dropbox?
Well, I didn't shut off Dropbox, but I also didn't try to synchronize it. But maybe you did.
No, I have Dropbox syncing shut off. I've learned.
Yeah. Okay. I will look into that as another possibility for what's causing the drop frames or whatever. Cool. Well, that's pretty exciting. I still feel like it was literally just Space Geek Christmas.
But where did the people who ask those questions?
Yeah, I know. You could support Elon Musk. They were. I would have just been enraged. And again, he said, what did he say? He said, questions, not essays, I think is what he said, or something like that.
The look on his face periodically was just sort of like, how do I share humanity with this?
Yeah. That was the worst. Someone
asked to kiss him. That's how ludicrous it was.
Yeah. Ugh. All right, let me see. I'm going to try turning off now people are giving me this great real-time feedback. So I'm going to make sure that Dropbox is killed. I'm going to make sure that Google Drive is killed. It's all dead. Maybe I've got some kind of
okay, so while
Windows
he's doing that,
thing going on.
Who are still with us? We have surveys up for CosmoQuest, and I want you to go take our surveys. I'm going to try and drop the links into the chat, and I think it's going to get shouty with me because that's what it usually does when I try and send things in the chat. So where there's supposed to be dots, I'm just going to delete the dots because that's usually how you get around it's trying really hard to not let me send things. So the survey that I most need help from people filling out is the survey for anyone who's ever done any citizen science. So this is, you've gone out, you've looked at birds for the Audubon Society, you've gone out and looked at mappers projects on CosmoQuest. So there's a citizen science one. So I just dropped the link in. And we also have one if you're a parent who's ever had to try and get your kid through science fair. We all know that's pretty miserable. And we're trying to figure out with CosmoQuest how to make it not miserable, how to make it fun to do science with your kid. And if you can take these surveys, then we can actually build things that you'll use. Because the problem is I'm a PhD astrophysicist who has no children. So I need you to tell me what you want before I help. And as for citizen science, again, PhD astrophysicist, I need to know what someone who doesn't have my particular 10 years of college and has a different 0 to however many years of college, what do you need to be successful at doing citizen science? So please take our surveys. Please.
All right.
Thank you. Please.
On that note, we should wrap things up. So thanks everyone for watching. Thanks to Pamela for bringing the knowledge. And thanks to all the fans for me debug my audio issues. Let's hope that I've gotten a little closer. I figured I could set my mic to mono. So I'm going to try that. I'm going to try and set the stream to mono as opposed to stereo. So hopefully the whole output will just remain as mono. So we'll see if that fixes it. Yeah. So what's happening next? Do we have anything happening until next week's Weekly Space Hangout? Do you have anything on Learning Space this week?
No. I can't think of anything. That may be a failure to be creative. But yeah. Okay. So that's all I know.
All right. Well, then enjoy the week. We'll see you all a week from now. Oh, apparently, when I did that live stream with Scott Manley, he's got a really great catchphrase like "fly safe" or something like that. So apparently, I need a catchphrase. So,
I have a catchphrase.
You do?
Yes. Have a great morning, evening, or night, wherever you may be in the world.
Oh, That's great. So anyway, if someone has a catchphrase for me, let me know. Michael, I can't stay on because I have to restart the streaming software to go to mono. So I'm just going to try that next week. So, all right. Thanks, everyone. Thanks, Pamela.
Thank you. More
now-
survey links. I'm seeing your questions. Go take our surveys.
I'm gonna say goodbye, but I'm gonna leave it streaming for a little while just so it doesn't get totally cut off. But I'm gonna switch to the intro. Let's see what happens. Here we go. Goodbye. Let's see, kill the desktop audio. Kill the mic.